Building automation is kind of continuation of some of the ideas we have already talked about in terms of reducing energy consumption. This is much more specifically about running the whole building with automation so that you again come back to managing the energy use, water use, comfort, livability, productivity, lights, air, humidity, etc., etc. It's ranked by 2050 at number 45 with 4.62 gigatons of CO2 expected to be reduced by then. The net cost is $68.1 billion and the net savings expected are $880.6 billion. This is an image of how this automation could work. There is an engineer looking at things, fixing things, and there is somebody with all the data that's being displayed and being adjusted. Well, it looks like a woman from the reflection. So it's all about collecting data, real-time weather, real-time people movements, real-time energy demand, real-time water demand, and other things like Wi-Fi use, telephone use, etc., etc. This figure we have seen already several times, but just to orient ourselves again, in terms of global greenhouse gas emissions, energy production is almost 3/4 of it, and in that we have energy use in the buildings at almost 17.5%, commercial at 6.6%, and residential buildings at 10.9%. How is the energy used within buildings? This is just for the US, but buildings use more than 38% of all US energy and 76% of US electricity. So the combination of energy use and especially electricity is remarkably high. So for 2014 we are looking at residential and commercial buildings primary use in quadrillion BTU, which is British thermal units. It's just good to get a sense of where all the energy demand comes from. So of course this depends on the latitude at which these buildings are. For the tropics this will be very different. So heating, cooling, ventilation, lighting, water heating, refrigeration, drying, computers and electronics, and then other are included in here. And for the same year, electricity sale for buildings, commercial, residential, almost the same. Other industrial uses at 24%, and industrial HVAC and lighting is at 3%. So this is what needs to be managed by building automations, the energy portfolio. So the building automation systems can result in up to 20% more efficient heating and cooling, the dominant energy uses, and 11.5% more efficient energy use for lighting, appliances, etc. So now you have tons of phones, laptops, TVs, games, video games, and so on and so forth, in addition to just cooking stoves, washing machines, dishwashers, etc. Expanding these systems from 34% of commercial floor space in 2014 to 50% by mid-century at an added cost of $68 billion. Building owners could save $881 billion in operating costs. 4.6 gigatons of carbon dioxide emissions could be avoided. So this also includes minor details, like when people mostly live as tenants, the building owner may end up choosing the systems which may or may not be efficient, environmentally conscious, net zero, etc. And then tenants end up paying for that system by living there. But building automation systems can compensate for smooth operation and efficient cooling, heating, and so on despite what the owner wants to do or how the owner makes choices. So building automation systems can make sure that everybody benefits, including the environment, especially the environment, and contribute to drawdown. So that's building automation systems. A short story there, but obviously a no regret solution as well.